Good morning. Today we begin Unit 7, Differential Equations. We are looking at initial conditions, which means that starting value. So given a derivative, students will find the original function. We've already touched on some of this a little bit, so we're just going to expand on that idea. Initial value problems. An antiderivative is a solution to a differential equation. So if dy dx equals lowercase f of x, if that's the derivative, y is equal to capital F of x plus c. And that's what we've been doing. We've been finding the integral of each side. So the integral of dy dx becomes that y, and the integral of f of x becomes that capital F of x plus c. And kind of looks a little bit more like this. Dy dx is equal to f of x. We're going to talk about this in a second, but we will multiply both sides by dx to essentially move it over here to the right. And then we integrate from there. So we'll talk more about that momentarily. We can find a unique solution if an initial condition is specified. And when I say unique solution, what I mean is we can solve for c. We can figure out what c is. So recall, find the equation of a line that passes through the point 2, -5 and has a slope of 1/2. So let's time travel back to Algebra 1. If we have y equals mx plus b, well, actually, we've got a few minutes this morning. We can do this a few ways. Y is -5. My m is 1/2. My x is 2. And here's my b. So -5 is equal to 1 plus b. B is equal to -6. So probably the first way you learned to do this was slope-intercept form, where you substitute the different values. So there's the equation line. And then we started to talk about point-slope form. Switch colors here. And in point-slope form, and we've been using that a little bit more this year, we know that y minus y1 is equal to m times x minus x1. So y minus a -5 is equal to 1/2 x minus 2. So y plus 5 is equal to 1/2 x minus 1. And if I subtract that 5 to the other side, I get y equals 1/2 x minus 6. Okay, same thing. So slope-intercept form, point-slope form, all that's Algebra 1. But what about calculus? So let's come over here. A slope of 1/2. Well, slope is the derivative, so dy dx is equal to 1/2. If I move that dx to the right that I talked about just a second ago, dy is equal to 1/2 dx. That's called separation of variables. We'll chat more about that in a moment. If I integrate both sides, what's the integral of dy? If I integrate that, well, it's just y. If I have 1/2 dx, that becomes 1/2 x. What do we have at the end? Plus c. All right, now we're talking. And now I have this point 2, -5. So -5 is equal to 1/2 times 2 plus c. And -5 is equal to 1 plus c. And c is equal to -6. So I've got that same thing over and over and over again. So you've been doing this. Now we're just calling that b, which was specific to a line, to a linear equation. Now we're calling it c because it doesn't have to be a line anymore. It can be any shape. It can be a parabola. It can be cubic. It can be quartic. It can be any shape at all, and we can solve for that c. So this is kind of interesting. In my algebra class, we're solving y equals mx plus b right now, and they're graphing lines. But here in calculus, we can graph anything. So example 1. Let's see what this looks like. I've given you a differential equation, dy dx equals 4x squared. No, excuse me, 4x to the 7th, and y of 0 equals 4. So just remember, y of 0 equals 4 is really f of 0 equals 4. It's really f of x on the left. So this is just function notation for an ordered pair, 0, 4. That's all it is. So if I come over here with my dy dx is equal to 4x to the 7th, we're going to separate those variables. So we multiply both sides by dx. dy is equal to 4x to the 7th dx. When I say separate the variables, you want all y values on one side and all x values on the other. You want to separate that differential, and get them on separate parts. So if we integrate both sides, y is equal to 4x to the 8th over 8 plus c. Let's simplify this a little bit. So y is equal to 1/2 x to the 8th plus c. If I put in that ordered pair, my initial condition, 4 is equal to 1/2 0 plus c. 4 is equal to c. So this becomes y equals 1/2 x to the 8th plus 4. That, folks, is our equation. Awesome. Now, let's zoom in here because we've got a lot going on. Solve dy dt equals sine pi of t, y of 2 equals 2. Well, let's switch colors. So dy dt is equal to sine of pi t. We want to separate that dt, get it over to the right. So dy is equal to sine of pi t dt. We have the y's on one side, the t's on the other. Don't forget that this is t, y of t equals 2. So this is really 2, 2. Come down here and integrate. The antiderivative of dy is just going to be y. The integral of sine is negative cosine of pi t over pi plus c. 2 questions. Why did I divide by pi? Because I did a real quick u substitution in my head. I said that u was pi over t, excuse me, and du is pi dt. So I need a pi in the problem. I need a 1 over pi in the front. So I divided. The other thing is that you might be wondering, well, if we just integrated the y, how come we don't have a plus c on the left as well? Well, you do, but we don't write it. So this is one constant, and this is another constant on the right. So if I subtract c1 from the left and put it over here with the x, it's still just a constant. So it's there, but we just group all the constants with the x values on the right-hand side just by convention. Okay, let's get rid of that. Ken, just putting it out there, it's early. Do those 2 pi's cancel? No, they do not. You cannot touch anything inside of this cosine, so those do not cancel. All right, what are we doing? We need to put in our 2's. So y is equal to 2, and t is equal to 2. So let's do this. 2, 2. Is equal to negative cosine of 2 pi over pi plus c. Remember, we're solving for c. So I can multiply, well, I guess let's come up with an answer. So unit circle, I know some of us are still a little unsure about that unit circle, but 2 pi is all the way over here to the right. You're at the point 1, 0. Cosine is the x coordinate, so that's your 1. And we have a negative, so this is negative 1 over pi plus c is equal to 2. So we can add 1 over pi to both sides. So 2 plus 1 over pi. Is equal to c. Oh my goodness, it's early this morning. There we go. So if we put it all together, y is equal to negative cosine of pi t over pi plus 2 plus 1 over pi. There you go. We solved for c. So this is your specific solution. If you have that plus c in there, that's considered a general solution. So specific solution and general solution. Now, let's see, we got lots of space here. Example 3, find f of x given f 2 primes of x is equal to 1 minus 2x, f of 0 equals 2, and f prime of 0 equals negative 1. I have seen problems like this, unreleased AP problems are very, very similar to this. So the second derivative is 1 minus 2x. So what happens if we integrate both sides? Well, the left-hand side will become the first derivative. We're just moving up one level. And then on the right-hand side, we need to integrate both of those terms. There's really dx over here. So the antiderivative of 1 is x. The antiderivative of 2x is negative 2x squared over 2 plus c. So let's clean this up a smidge. So we have our first derivative. Now we have this little piece of information. It looks like it's not huge, but it's actually really helpful. So that -1 goes in for the left, and 0 is all of your x terms. So c is equal to -1. So my first derivative is x minus x squared minus 1. Okay, great. Now we want to go all the way up. We want to get to the original function, f of x, not f prime of x. So we are going to integrate again. Let's use a new color. This is a slightly different green. So the antiderivative, or the integral of f prime of x, is just f of x. The integral of x is x squared over 2. The integral of x squared is x cubed over 3. The integral of 1 is x plus c. Go back to that given information. F of 0 equals 2. So now we say that 2 is equal to 0 minus 0 minus 0 plus c. So c is equal to 2. So if I put all of this together, f of x is equal to x squared over 2 minus x cubed over 3 minus x plus 2. Excellent. Now, this might be, maybe you know this already, but maybe you don't, because it's just, it's 2020. It's weird year. But don't forget that this can be also written as 1/2 x squared minus 1/3 x cubed minus x plus 2. That they can be written exactly the same way. All right, great job. So what happens when we apply this to word problems? Position, velocity, and acceleration. I'm not exactly sure what the intention is for words up here, but remember that we have our position. The derivative of position is velocity. The first derivative of velocity is acceleration. And so that's the second derivative of your position. So if we go down this list, we can find the derivatives. To go up, we would integrate. So example 4, at time equals 0, the velocity is 96 feet per second and slows down at a constant deceleration because it's negative. So it's a negative acceleration. So it's deceleration of 12 feet per second squared. Find v of t at time t and the distance traveled until it stops. All right. So we need to start with acceleration. We need to start down here at the bottom of the list. So a of t is equal to -12 feet per second squared. So to get to the velocity, we need to integrate. So v of t is equal to -12. We're dealing with t, not x here, plus c. Sorry, I had to go wake my daughter up. So my v of t is equal to -12t plus c. Now, all the important information that we need is there. It's just a little bit tougher to find than the last one. When we have f of x equals y, whoops. When we have f of x is equal to y, or f of 2 is equal to 7, it's a little bit more straightforward to see what the x value is and what the y value is, or what the t value is and what the y value is. But all the information that we need is here. I just gotta look for it. So we know that we have 96 feet per second is my velocity, but when did that happen? It happened at time equals 0. So that's really the ordered pair that we're going to use is 0, 96 for time and velocity. So if it helps you to rewrite it, go for it. So the velocity at 0, this is going to be 96, is equal to -12 times 0 plus c. So 96 is equal to c. Now, if you have been through physics, maybe some of this is starting to look familiar. I do want you to keep using the calculus equations. I want to see derivatives. I want to see integrals. Your physics formulas come from all of that, but you're taking, most of you are taking physics where it's assumed that you haven't had calculus yet. So they just give you the formulas. When you get to college, if you're headed for one of those engineering or heavy science classes, you're going to take calculus-based physics. So all of these will start to come together again. Anyway, I digress. So my V of t is equal to negative 12t plus 96. So there's my velocity equation. So we have V of t at time t. Excellent. Now, the distance until it stops. Well, what happens when it stops? Velocity is 0, right? So when it stops, let's shrink this down a little bit. When it stops, the velocity is equal to 0. So let's set this equal to 0, see what happens. So 0 is equal to negative 12t plus 96. The 12t equals 96. T is equal to 96 divided by 12, which is 8. So it takes 8 seconds for it to stop. But that wasn't the question. The question was, find the distance until it stops. Distance traveled until it stops. So far we have acceleration, we have velocity. What else do we need? You need position, you need distance. So let's revisit this velocity equation back here. So V of t is equal to negative 12t plus 96. If we integrate this, the integral of velocity is position. So S of t is equal to negative 12t squared over 2 plus 96t plus what goes on the end plus c. Good. So S of t is equal to negative 6t squared plus 96t plus c. Now, this 8 seconds until it stops, that's a t. We're going to put that in for t. However, before we get there, what's missing right now? What's causing us some issues? Yeah, this plus c, we have to figure out what it is. Sorry, I wanted to shrink my work a little bit. It was starting to get really, really big. So my position is negative 6t squared plus 96t plus c. Here's that piece that's implied that's a little bit tougher to see that I was alluding to earlier. At time equals 0, it tells us the velocity is 96 feet per second, and it slows down at a constant negative 12 feet per second squared. Find the velocity and the distance traveled until it stops. Well, we have this particle, whatever it is. It starts here and then it's slowing down, right? So at time equals 0, that's my dog. At time equals 0, we know that the velocity is 96 feet per second. We figured out over here at time equals 8 that the velocity is 0 because that's where it stops. And we're trying to figure out that distance, how far did it go? What we need to do is talk about time equals 0 again. You can actually say that your starting position is also 0. And we'll figure out what it is over here. So at time equals 0, my position equals 0. You're at the beginning, you're at 0, 0. So let's take our position. Let's say S of 0 is equal to negative 6 times 0 squared plus 96 times 0 plus c. And this is 0. My position is 0. So 0 equals 0 plus 0 plus c. My constant is equal to 0. My constant is equal to 0. So S of t is equal to negative 6t squared plus 96t plus 0. We don't need that at the end. The distance traveled until it stops. Now we can put that 8 in, that 8 seconds, the position at 8. It's negative 6 times 8 squared plus 96 times 8. All right. That mental math is definitely not happening this morning. -6 times 8 squared plus 96 times 8. 384. What units do we have? Feet. Feet. So in those 8 seconds, it travels 384 feet. All right, there you go. Differential equations. This is just the tip of the iceberg when it comes to differential equations. Those of you starting to think about, college and majors and careers and all that other stuff, what's coming next. So if you're headed for school in engineering, which a lot of our Easton students love to head off for engineering, in school you'll be looking at Calculus 1 for sure, Calculus 2 for sure, Calculus 3 for sure. Depending on the school, they might call it Calculus 4 or they call it differential equations. So you have this entire course dedicated to just differential equations. Math majors would be doing that much as well. If you're doing a science, like a biology, chemistry, biochemistry kind of major, Calculus 1 and Calculus 2 for sure. Depending on the program, you might need to go a little bit higher too. So all of this, hopefully you'll be using in your futures. Try a couple Edpuzzle questions for me and just practice differential equations. Let us know if you get stuck.